Scripts are the heart of Windows PowerShell 3.0. In fact, if you ask anybody who knows anything about PowerShell to describe it, they'll probably call it a scripting language. Now, whenever you're in the PowerShell console and you're executing a series of commands, technically you're writing a script. But generally speaking, what we mean when we talk about scripts are text files with a PS1 extension. Now, in order to execute scripts, you have to have previously set up your execution policy to allow scripting. In the demonstrations I'm going to do here, I've got my execution policy set up to remote sign, so anything I do locally is going to work. And the reason people write PS1 files or PowerShell scripts is to perform complex operations. Probably most scripts that get written are written for one-time use, and after that they're not important anymore. But you can really do some complicated things with scripts, and they can be reusable. PowerShell scripting is a complete language. It's got conditional operations and loops and variables and all of the things that you would expect from any normal full-blown computer language. And it's also possible to create commandlets using script. One thing that usually throws people off when they start using PowerShell is the somewhat peculiar way PowerShell treats paths, certainly as compared to the command window. The thing you need to know about paths is that they are always required. Now, this isn't as bad as it seems. You could do it explicitly, but that's kind of icky when you've got 10 directories nested inside of each other in a really long path. So PowerShell will also let you use what's called dot sourcing. And dot sourcing basically means from whatever folder I'm in now, which is what the dot represents, in the subsequent path you will find a script that I want you to execute. And then finally, a great tip with regard to paths in PowerShell is that you can always use the path environment variable. And when you put a folder in the path environment variable that contains PowerShell scripts, you don't have to provide the path as part of the command line operation. It will just find it based on using the path environment variable. Alright, so let's get started with some scripting. I'm going to use PowerShell ICE 3.0, and since this is the first scripting demonstration I'm going to do, this will of course be the obligatory Hello World demo. Alright, so here in ICE I have two panels visible. The first one is the console pane, and the other one is the scripting pane. And so this time I am going to write some script inside of the scripting pane. Now, just to review, I have previously set the execution policy of this machine to allow scripts to run via the set execution policy command. And my execution policy is set to remote signed. Alright, I don't need to run this again because I've already run it once. So let's just come up here to the scripting window, and I'm going to start by creating a variable with my name in it. So we'll call this variable name. All variables in PowerShell start with a $sign. And so we'll say that this name is going to be equal to Doug Ware. And then what we'll do is we'll just write that out as output to the host window. All right, so we'll say write host hello $name close quote. It's also a little different from some languages that you might be used to, where I can just use the name right inside the string and have it work. All right, now if I come up here and hit the run button, we'll see that what actually happens is it puts from my unsaved script the lines into the console window and actually executes them. So what we see here is my script followed by its output. This is exactly the same thing as if I just copied that and pasted it into my console. Alright, so if I want this to be a persisted script, then what I need to do is save it. Alright, so I'm going to hit the save button here, and I have a scripts folder that I've created previously, and we'll call this script hello. Alright, now if I come up here and hit run, you can see that PowerShell adds the path which is necessary to the command line. So I get C scripts hello.ps1. If I were in the scripts folder, then I could simply type .tab, and you can see the IntelliSense, or // rather, the IntelliSense pops right up and gives me my command, and I can just select it and hit enter. And if I were to type hello.ps1 right here, then I get an error because I have not supplied the path either explicitly or as part of a dot source. So if I'm going to be doing a lot of scripting on a machine, and I want to make it really easy for myself, then typically what I do is I set the path environment variable. Now the path environment variable can be set through PowerShell permanently. I'm not going to show you how to do that just now. It can also be set through Server Manager. So if I go to Change System Properties and go to Advanced, then under all of these is an Environment Variables button, which I can click, and I can see that I have a path variable. I'm not going to change it here either. What I'm going to do is, just in my temporary PowerShell session, I'm going to go ahead and set the path just to demonstrate this. So the environment variable is built in, and it's called env::path. And if we look at this now, we can see that that's the path that I have. So what I'm going to do is I'm just going to set this equal to what it is already. And then to that we'll add the scripts folder. So this is C:\scripts, and I just hit enter. And now, because this is in my path, I can just say hello. I don't even need the .ps1 extension on the file. Right? So let's go back over to our original location and just prove that this actually works. Just going to copy this to the clipboard, and we'll just change back to that directory and type hello, and you can see that the script still works. Now once I've got a script and it's been saved, I can use it either interactively from the console window, as you see here, or I can do it inside of another script. So I'm going to come up here and I'm going to make a new script file, and in this one we'll just say rate host say hello, and then we'll just say hello. Now I can't stress enough that if you're going to mess around with the path, that you are creating a dependency on the environment. And so if you're going to create any kind of script that's intended to be reusable, and it might move from machine to machine, you need to give some thought to exactly how you're going to go about this in order to keep it as portable as possible. But now if I run this script, you can see there's the rate host say hello, and then the command hello, which is actually my script, and we see say hello, hello Doug Ware. Now one thing that's cool about ICE is that it's possible to debug our scripts. There is a little gotcha here. It's a little bit tricky for people. If I right-click hello in Untitled 2PS1, you can see that toggle breakpoint is grayed out. And the reason for that is because you can't set a breakpoint on a file that hasn't been saved yet. So let's go ahead and save this, and we'll just call this, we'll leave this called Untitled 2. That's as good a name as any. And now if I right-click on here, I can toggle a breakpoint, and also in hello PS1 we'll toggle a breakpoint right here as well. And now we'll run Untitled 2. Would help if I spelled titled correctly. So this is Untitled 2. And you can see that it hit a breakpoint on line 1 and stops right here inside the debugger. And if I press F5, it'll keep running until it gets to the next breakpoint, which is in the next script. And there's a little hover over capability here. So if I hover over the name variable, we can see that it's equal to the value Doug Ware. And there we go. Right now you're armed with the basic knowledge that you need in order to do scripting, which is you always need to have the path, or dot source it, or put it in the path environment variable. And of course the prerequisite for this is that you need to set the execution policy on the machine. PowerShell's been around for quite some time now, and I have to admit that when I first saw it, I didn't really know what to make of it, and I wasn't that interested in using it. You see, I run the Atlanta.NET user group. I've been a .NET developer for 10 years now. I'm a SharePoint MVP. I do a lot of work with SharePoint. And when I saw PowerShell syntax, I thought, well, that's great that it's built on .NET, but why on earth would I want to learn this weird syntax when I can just write a C# executable to do whatever I need to do? Well, when SharePoint 2010 came out, they made a significant shift to PowerShell, and I had no choice but to get with the program. And I still struggled a little bit with it. That was until I went clear back to 2002 and really came to terms with what it is that they were trying to do with PowerShell. You can do the same thing, because way back in 2002, Microsoft released a document called the Monad Manifesto, and that document is still available online. Like I said, it was published in 2002, and what it is the vision document for what PowerShell was going to become. Now, it is not a terrific technical reference for PowerShell, but it is very informative still to this day. So let's go back to 2002 and talk about some of the problems that the team who built Monad, which was the code word for the PowerShell beta, were trying to address. The first one is that Windows scripting requires system programming. So there was C script and Windows script, and you could do scripting as an administrator, but you really had to talk to Windows through some really deep, nitty-gritty APIs, and it was hard to do. And what they really wanted was, instead of having a high-level language that talked to a low-level API that was really hard to understand, was a high-level API that they could call from a high-level language. The thing is, in 2002, if you could do VB script to do serious administrative work, you probably had the skills of a developer and you were not an administrator. And so the tools of the day did not address the audience that they were intended to serve. So Monad's first goal, in a nutshell, was to make it easy for Windows administrators to do scripting, a tool that they could actually use productively. They were going to do that by supporting the creation of commands called commandlets that performed atomic operations. So instead of having to execute a dozen API commands in order to create a website, it would be nice if there was a commandlet called create website or something similar. And they didn't want to just dump this out there and go, here's your kit of commands that you can use. They wanted to provide a runtime environment that would let commandlets work together easily and let people extend their environments by creating new custom commandlets. And the tool that this was all going to sit on top of was the .NET Framework. So as an example of what I'm talking about, consider the script that you see here on this slide, which gets the contents of the event log. Now this is from a random blog off of the internet that I selected just for an example script. And what this does is first it gets the machine, and then it gets the event log, and then it loops through all the entries inside of the event log to build an array, and then it takes that array and it walks through that again and writes out all of the event log entries to the console window. All right, so we're looking at, I don't know, a dozen or more lines of code in order to do that. Now compare that to the equivalent PowerShell, which you see here, which is just a commandlet called getEventLog that takes the log name as an argument. Well, this is much more accessible to an administrator, and when you consider the auto-completion capabilities that we now have in PowerShell 3 in the ICE tool, you can see that this, as an example, certainly meets their goal of making things easier for administrators. I think it's fair to say that in 2002, the state of Windows scripting was pretty pitiful. And so the Monad team, instead of looking at Windows and going, okay, what are we going to do to Windows to improve upon it, they thought, well, let's go take a look at Unix and take inspiration from it, because Unix has always had really good administrative scripting capabilities. So Unix has a variety of programmatic shells that you can use, like Corn Shell and Bash, and it's got a nice set of high-level administrative commands or daemons like kill and ifconfig, and it also has a really good set of text manipulation utilities in awk, grep, and sed, and it works really well. So in Unix there are also administrative GUIs that are layered on top of all of these commands and utilities. But the thing is, although they drew inspiration from it, they also realized that Unix scripting could be a lot better. One of the problems with Unix scripting is that the traditional approach is inefficient because there's no standards. So the commands that you find in a typical Unix environment are homegrown with no real standards. And when I say homegrown, I mean even the ones that are in a distribution that you might install today. Those were written back sometime in the past because somebody had a specific need and the command that they wrote was useful enough that other people started to use it. And each one of them was probably written in C or in some cases other languages, but there was no shared automation model for common scenarios. Everything kind of did whatever it did in its own way. One thing that was and is very good about Unix is its support for pipelining, which is the ability for one command to emit data, which is then sent into the next command through denoted by a pipe symbol. We're going to look at that in just a second. And then the next command can process that. But to the point that Unix scripting didn't have standards, the commands that pass data through the pipeline do so as text. And as a result, the thing that receives the command pipeline has to parse that text. So it needs to understand the implementation details of the command that it's going to handle in order to process. So to address these points, the Monad team decided they needed to make a few improvements. The first one is that they were just going to use the .NET framework as a basis. So you could use any language you want because it's the .NET framework, but under the covers, the core data types and objects were going to be the same because they're going to run on top of the same framework. And so as a result of this, PowerShell literally can do anything the .NET framework can do. So the day that the Monad beta shipped, it was incredibly powerful because it had access to the entire .NET framework, which at that point was in .NET 1.1. By using the .NET framework, it enabled them to pass objects around instead of passing text around. And that means there's no need to parse anything, unless of course you're writing some sort of text parser. But you don't need to understand how to catch the formatted results of a command that lists the files in a directory, because you would get a collection of objects that you could play with. And then finally, they wanted to, right out of the box, transparently support remote automation using web services with .NET. Now, of all of these things that I just talked about, if you're a .NET developer, the thing that you probably are going to have the hardest time understanding initially is the object pipeline. Now, the object pipeline conceptually is really easy to understand. Basically, what it does is it sends the output of A to B, and the operation is denoted by the pipe symbol. Now, that operator can be used to combine any set of commands, or commandlets rather, as long as the commandlet that receives the pipeline is set up to do it. It's got the it understands that kind of input. Because the output of A is going to be a .NET object, there's not going to be any need to parse whatever A sent to B. It just needs to know what to expect, and it can iterate through that collection. All right, so I've got some really simple demonstrations we can look at that are going to make this crystal clear. Let's jump back over to our test machine and take a look at some pipeline operations. All right, so what we're going to do here is start off with a simple command that can give us the contents of the current folder that we're in. And this command in PowerShell is called getChildItem, and it works just like the dir or ls commands from DOS and Unix respectively. Right? So if I say getChildItem, I can see that in the current directory I have a variety of folders, and then there's a text file in there as well. Now let's say that what I was really interested in were the contents of this folder that started with the letter D. All right, so what I'm going to do is I'm going to pipe the output of getChildItem to another command, which is whereObject. It's aliased to the simple text where. And what I'm going to do is I'm just going to write a little expression in here, and I'm going to say where $_ which indicates the current thing that I'm processing from the pipeline. And you can see that I have full IntelliSense here. So we want to say where the name is like, and we'll say D. All right, so this is going to take all of the items that came from getChildItem, which you see on the window here, and pass them into whereObject. And if the name starts with a D, then it's going to narrow down the collection to those things and spit those out. So let's hit enter and see what happens. All right, cool. So we can see we have desktop, documents, and downloads. Now let's say I want to furthermore sort this so that I can get whatever folders are least active first down to most active. So I could take that command that I just ran and add another pipe argument to it, and this time instead of using where to filter it, I'm going to use sort. And sort, I just need to give it the name of the argument that I wanted to sort on, and so we're going to sort on last write time. And if I hit enter here, we can see that it's now changed the sort operation to downloads, which is the earliest one to have been written to, then documents, and then desktop. So this is looking pretty good, but maybe I want a different format for it. Well, there's also a set of formatting commands in PowerShell that also accept pipeline operations. So we can take this exact same line of code and add another pipe to it, and this time we're going to format it. And we'll try, let's say, format this as a list. And you can see that I get a very different looking format to what I had before. So this is a really simple demonstration, but hopefully you understand what's going on here. At each stage of the pipeline, something happens and the command returns a collection of .NET objects. And each time we pipe to the next command, whatever that output is passed in, the command produces another collection of .NET objects, which either gets written out to the host or continues down the pipeline. So the object pipeline example that I just showed you makes things simple in that the commands don't need to do any parsing, and the way it works is kind of intuitive. But at the same time, it makes things a little bit more complicated for an administrator, because administrators don't typically use getChildItem in order to deal with the contents of folders, right? They use the dir command in DOS and they use ls in Unix. And so to accommodate these people, the command shell commands work in PowerShell, the ones that you're already used to, and they work by aliasing existing commandlets. This is both DOS commands and Unix commands that get aliased. And because they're aliased instead of actually just being the original dir or ls command, those command shell commands will work with the object pipeline, because an alias is just another name for the same thing. So PowerShell has alternatives for all of the common DOS and Unix commands that people would use, and there's even a commandlet that comes out of the box called getAlias that you can use to view all of the different aliases that you have in a given environment. All right, so let's take a look at that. Instead of using getChild, we'll see what happens if we try to use dir or ls. So if what I told you is true, I should be able to take this command that we just ran, getChildItem, and just delete this and change this to dir. And you can see that it still works. And I can also change dir to ls if I'm a Unix admin, and it also still works. I can see all of the aliases that are available to me out of the box, or in my current PowerShell session actually. This is going to be driven based on what I have loaded up. But I can do that with the get alias commandlet. And you can see that there are a whole bunch of different commandlets in here, or rather aliases in here. In that demonstration I was doing with the pipeline, I used sort, and I mentioned that sort was an alias for sort object. And I also used where, which is an alias for where object. And if we scroll up here, you can see that we've got remove item, rm, remove directory. These both alias the same commandlet. And so in most cases, the PowerShell commandlet itself is going to be at least as functional as the thing that's aliasing it, but usually much more functional than the thing that it's aliasing, or that's being aliased. And that's why we use remove item to remove a folder or a file. Well, this is a big long list, right? So if you're not sure exactly what a particular alias is aliasing, you can just pass it as an argument to the getAlias function, right? And so we could say getAlias dir, and it'll tell us that dir alias is getChildItem. Now, of course, there is an inverse to getAlias. PowerShell always follows a proper verb-noun convention, which is standard, and so the opposite of a get is a set. And so instead of getting an alias, we could set an alias and say that I wanted to make my own alias for the getChildItem command. Maybe we'll call that alias instead of dir. And the value for this is going to be whatever the heck it is we're aliasing. So I would say getChildItem and hit enter here. And now if I type we get the child item collection from the folder that we happen to be in. And of course, if we do getAlias, we'll see that that's aliasing getChildItem. The last major goal of the Monad team was to make it easy to do remote scripting. There are some commands or some commandlets that work remotely without any configuration required. They sit on top of some older APIs that can be found in all versions of Windows. These commandlets all have a computer name parameter, and they're missing a session parameter. Examples are getEventLog, which can get the event log from whatever machine you tell it to, and restartComputer, which can restart whatever machine you want to restart. But there are also a whole set of PowerShell commands that support actual remote scripting. In other words, the ability to run scripts that are defined on one machine on one or more other machines. And so it's possible that you could sit at an administrative console and actually manage thousands or tens of thousands of machines if you wanted to. PowerShell actually supports that. All right, so what we're going to do now is take a look at a different demonstration computer that I've set up. This one uses SharePoint 2013, and it's part of the domain that has another server which runs the web applications, or the Office web applications, as well as Azure Workflow Services. Now that's going to be a nice little environment that we can use to test this out and see how remote scripting actually works. Okay, so here we are on the SharePoint machine, and I have gone ahead and opened up a remote desktop connection to another server, which is called Workflow and WAC. All right, so before we start looking at a remote session, let's take a look at the commands that we can use without having to do any setup. Right, so this is remote without config, and I can look up the commands that are available by using the get command commandlet and passing it down the object pipeline and checking some parameters. So what I'm going to do is I'm going to filter this, and the filter is going to be where the parameter parameters.keys contains computer name. And where the parameters keys does not contain a parameter called session. Because if it's got a session, that means that we connect with it interactively with setup. All right, so let's run this. And you can see there's a decent number of commands that are here. We can rename a computer, we can restart it, change its services, write to its event log. What we're going to use here for this demonstration is the get process command, all right, which is right here. And what get process does is it gives us information about processes on whatever machine we're interested in working with. So I'm going to say get process, and the first argument this takes is of course computer name. That's the thing that we were just checking, and the name of this computer is workflow and whack. And then I need to say what process am I actually interested in. So workflow and whack has got IIS installed on it because it's got Office Web Apps. So let's check out the W3WP worker process, and you can see that PowerShell is actually telling me which processes I might be interested in. And this is actually based on the computer I'm on, which happens to be running IIS as well, because it's SharePoint. And I can see that I have a whole bunch of web worker processes running on this machine. Now, this network here that we're working on also has a domain controller. So let's try to get the worker processes for the domain controller. And you can see I get an error. There are no processes called W3WP. But of course there are processes that are running on the domain controller. Let's just do a check for Explorer. Alright, so the ID of the process is 1000, and this should give you some pretty decent assurance that we've actually been able to talk to both the domain controller and the server called Workflow and Whack without doing any setup. I haven't done anything special here. But now I would like to actually enter into a remote PowerShell session to interactively work with the Workflow and Whack machine. So I'm going to say I want to enter a PS session, and this just takes the name of the machine. Alright, now this failed. It told me access is denied, along with a help topic that I can look at to troubleshoot this. I actually know what the problem is in this case, and that is that I have not done the thing I need to do in order to make remote PowerShell possible on that machine, which is to actually enable it. Alright, so that's why I have this remote desktop opened to it already. So over here, I'm going to open up another PowerShell window. And the command that I want here is called enable, and it's enable PS remoting. And what we're going to do is force this. Alright, so enable PS remoting force, and I hit enter here. And I've done this on the machine previously, so it gave me some different messages than what you would see if you were doing this for the very first time on a machine that had never had remoting enabled. And those messages are going to tell you that it's set up WinRM, which is the remoting management, that it has opened a firewall exception for WinRM, and done other things that are necessary in order for that to actually execute. And you can actually see what these are, because if I say to disable it, it's going to tell me that although this disables it, it does not completely undo all the changes that might have been enabled by the enable command. So it wants me to stop and disable the service, delete the listener, disable the firewall rule, etc. and so forth. So let's just go ahead and turn this back on. And now, if I come back over here to my machine and try to set that session up, I can see that it was successful. Aside from the fact that I didn't get an error message, it tells me here on the prompt that I am currently connected to Workflow and WAC. And so the directory that I'm in is cusersadministrator.sp2013 documents. And so I can work with this just as if I were on that machine. So if I do a directory command, you can see that there's nothing in that file right now. And I don't know, let's try to pipe, or rather let's redirect the output of a dir to be a text file. Okay, so now if we do a listing, we can see that there is an actual file there. Well, is there really an actual file there? Let's come over to that machine and take a look at our documents, and you can see, well, bada bing, there in Workflow and WAC we have created a text file. So once I've connected to it, I can do all sorts of things to it just as if I were sitting there without having to open up a remote desktop connection. Now, when I'm done working with it, I just need to exit the session. And now you can see that the Workflow and WAC has gone off the prompt. Although I'm the same user, I'm not in documents. But if we do a directory over here, you can see that this is clearly a different machine.